In this section, we're going to discuss some concepts about how to think in object-oriented ways. Data association is the idea that two different objects can talk or refer to each other. Primitive data types represent single values, as we've seen. Arrays represent multiple values of a single data type, but there is no simple way to this point that we have to associate different data types together in a way that's hard to make a mistake. We could have parallel arrays, and then all the data would be indexed by common numbers to associate that data. But it's easy to get the indexes off a bit and grab one piece of data from this index, a different piece from a different index, and get mismatches. A class is a mechanism by which we can put together or associate different data types in one unit that makes access to them guaranteed and very hard to mess up. The object returns its significant data, which is defined by its interface. That is, what the external client code sees is well defined, and only those interactions can be done. Client code cannot look directly inside the object and see or manipulate its data. For example, a student class would have an object that we could ask, what is your name? And we could also ask it what its GPA is. Name would be a string, GPA would be a double, two totally separate data types, but they're related to each other in the idea of a single student. One great difference between primitive data types and objects is that objects can be considered more alive or active. That is, they can be asked questions such as what is your X value or please perform behavior Y, and we expect them to do that correctly. Primitive data types are much more passive. We just simply assign them values or extract those values from them. This activeness allows instances to interact with each other or collaborate and presents a consistent, meaningful way of manipulating objects and their data. We would treat each one the same way. We access them using the same scheme. Tying data and actions on that data into a single object is a major key to object-oriented programming. Try to think as much as possible about designing classes that are self-contained. That is, they represent as much of the necessary data as possible. Encapsulated, the data is hidden away and available to clients only through the public method interface that's presented, and meaningful. That is, enough data to help a client actually solve a problem. Our example of the student is that we would model sufficient data per student object to represent meaningfully what a student is for our particular type of problem. We would be sure to have name, GPA, and various other pieces of data that help us manage students taking classes at a school.